Hello everyone, welcome back to my vlog, or I guess just my YouTube channel. Make sure you like and subscribe at the end. But this is going to be number 5 on Unit 7 Homework 1. So I feel like this one's pretty hard and you might need some help with it. So like the point of this isn't for me to do it for you. The point of this is to make sure that like you can explain it from like beginning to end. So if you can like explain this one, like all the steps, then you've mastered the concept and you can do your test because this one's really hard. Okay, so it says a particle executes simple harmonic motion with some amplitude, and mine is 3.21 centimeters, yours is something else. And it looks like that's the only thing we're given. And we have to find the displacement from the midpoint of its motion where its speed is equal to 1/2 its maximum speed. So you can imagine like simple harmonic motion, so like something on a string, or not a string, a spring. So here's my spring, and like here's my mass, and then we're gonna displace it some amounts. I'm gonna call it x max. So my x max is 3.21 centimeters, yours is something else. And then it's gonna move back and forth, right? Because if you stretch your spring, then you like displace it from equilibrium. It's gonna wanna go back towards equilibrium, but then it'll keep moving because it keeps moving. There's like inertia. And then it'll go away from equilibrium, and then the spring will push it back towards equilibrium, but it has inertia, so it'll keep moving. Then it'll be away from equilibrium, and then the spring will pull it back towards equilibrium, but it has inertia, so it keeps moving. So it'll be away from equilibrium, the spring pushes back, and it's a complete cycle. So the point is, like, you displace it, and you make it in simple harmonic motion. And we have to find at some point, it's like, maybe I'll do that in pink. So like right here, I'll call this x, and we want to find this x where its speed is 1/2 its maximum speed. So you may be confused on where to start, but if you don't know where to start, like think about what you do know. So I know at the maximum displacement, if I stretch my spring at the furthest, I have all spring potential energy. So I do my pie chart. And when it's at the midpoint, so like when it's at equilibrium, then this spring's like not compressed. And so then I have all kinetic energy because it's going to be moving. And at the point where we want to find where its speed is half of its maximum speed, we're going to have both kinetic energy and spring potential energy because we're moving. So there's kinetic energy, and there's spring potential energy because our spring isn't like, our spring's still stretched, right? It's not at equilibrium. So at the point that we want to find, there's going to be some kinetic energy and there's some spring potential energy. Right? The amount doesn't really matter. You just have to know that there's both of them there. So when I do my pie charts, the next step is to write your conservation of energy statement. So then we have two US's. So I'll make a distinction between the two. So the maximum US, the maximum displacement, I'll call it US max. And then the one we're trying to find, let's call it like normal spring potential. So then we got kinetic energy is equal to, I guess we got two kinetic energies. So do kinetic energy max. The maximum kinetic energy is equal to the kinetic energy at the point where we want to find the spring displacement. So that kinetic energy, like this one, plus that spring potential energy, it's a U, not a V, that one, is equal to the maximum spring potential energy. So then once you've written your conservation energy statement, you have to then like substitute your equations. So I'm gonna go back to my formula chart, and now we're at energy, all the way back in unit 3. And we want kinetic energy and spring potential energy. So I'll just go ahead and copy these equations over so that we have them. Okay, so kinetic energy is 1/2 mv squared. So I'll do 1/2, whatever the mass is, times v, and it's the maximum kinetic energy, so we'll do maximum velocity squared, is equal to 1/2 mv squared, and this v is going to be 1/2 v max, right? I'll just, because that's what the problem says. We want to find where the velocity is, like 1/2 plus our spring potential, so 1/2 kx squared. And remember, you can't forget what you're trying to solve for. We are trying to solve for this x right here. Then plus, or no, then equals our maximum squared potential energy. So 1/2 times k times x maximum squared. Right, so what our initial displacement. Again, mine is 3.21, yours is something else. Cool. So if we look at our equation, we're looking for this x that I circled in pink, but we have so many unknowns, right? We don't know this mass. We don't know, what else? We don't know k, but we got to take it one step at a time. So since we don't know k, we probably need another equation to solve for k. So I'm going to go look at my simple harmonic equations, look for something with k. So you choose like the easiest one. It's like the easiest one's like spring force, but that doesn't really help us because we don't know that x either. So I'm not going to use that one because we don't know how far we displaced our spring. So then the next one with k is like this one right here. So this omega is angular frequency. It's like frequency, but you're in a circle. And then this f is normal frequency, this t is period, and this one has k. So you can choose any one of these to solve for k. I'm just going to choose the one that looks the easiest. So I'm going to use omega because it's like one thing. So I'm going to write off to the side, omega is equal to square root of k divided by m. So then if I solve for k, so then that'll be like omega squared, right? I'll square both sides, and then I'll multiply by m. So omega squared multiplied by m equals k. So this is nice because anytime I see a k, we'll put omega squared times m. Okay. So if we're looking for k, right, or we're looking for this x. So I'll just write 1/2 m. Instead of v, I'll put 1/2 v max, right? So 1/2 v max whole thing squared plus 1/2, and then k, right? K will be omega squared over omega squared times m x squared is equal to 1/2. Then k, instead of k, will be omega squared m x max squared. Okay, so we're getting closer. Okay, to make our lives easier, since there's a 1/2 in each term in our equation, we can go ahead and cancel out the 1/2, so I don't have to write it. And there's also an m in each one of our equations, right? M, so we can cancel that out too. So then it ends up being 1/2 v max squared, whole thing squared, plus omega squared x squared is equal to omega squared x max squared. Okay, so we're getting a little closer. So we don't know omega. We also don't know v max. So we're probably going to use like the other part of our equation that I didn't write. So then I'll write like a new equation. So it's 1/2 m v max squared is equal to like this one, because we know that is equal to 1/2 k x max squared. So I'm not using the one in the middle because we don't know x, but we do know x max. So I'm just using the equations that we have the most information to make it like as easy as possible. So again, just like I did before, instead of k, I'll put omega squared times m. And I can go ahead and cancel the 1/2. So m v max squared is equal to omega squared m x max squared. So I can go ahead and cancel the m's. And then you can take the square root of both sides to undo the square. So that means v max is just equal to omega x max. So now we have v max, right? We just want 1/2 of it, so I'll just multiply both sides by 1/2. And then we have an equation for 1/2 v max. And that will go there. So it'll be, we'll go 1/2 times, 1/2 omega x max whole thing squared plus omega squared x squared is equal to omega squared x max squared. Okay. So we can go ahead and distribute the square to everything inside the parentheses. So 1/2 squared is 1/2 times 1/2, which is 1/4. It'll be 1/4. Omega squared is just omega squared. X max squared is whatever x max squared is. Then plus omega squared x squared is equal to omega squared x max squared. So now, look, there's an omega in each term. So those are gone. So now we're just left with 1/4 x max squared plus x squared is equal to x max squared. So then you know everything, right? Because you know the maximum displacement. Again, mine is 3.21. Yours is probably something different. So then you would just like combine like terms, get all your unknowns on one side and get all your knowns on one side. So again, we're looking for this x. So I'll subtract this x max squared on both sides. So it will be x squared is equal to, so 1 x max squared minus 1/4 x max squared is 3/4 x max squared. Say that 3 times fast. And then you can do it, right? You do the square root of both sides, do whatever you want to do. But there's your equation. But you got to go through all the steps, right? So even if you don't know something, start with what you do know and you just keep going. So even if there's like a variable that you don't know, if you do it right, it'll cancel out and it'll be okay. So there's how you do number 5. So good luck with your number 5.